All right, previewing our exponents and growth and decay stuff for tomorrow's test. So for the moment, I need to move the help sheet out of the way so I can actually see the questions. So again, simplify. Our answer is going to contain just positive exponents, which isn't a bad thing because, well, we've got all the rules to help us anyway. So when we're doing these, and remember, these only go what's on this sheet for exponents, for variables. Any values that I have in front, any coefficients I have in front, I'm still just going to multiply them like I always would. So 3 times 3 is 9, times 2 is 18. And then I go from variable to variable, trying to find what that would be when I put them together. And again, when we're multiplying with exponents, we're just going to add them up. So 2 and 4 on my x's gives me 6. And then with my y's, I've got 3, and there's another 3. What exponent's on this one? Because I don't see one. 1. So 3 and 3 is 6, and 1 more is 7. And I'm good. But I have to be able to keep that stuff straight. I can't add 3 plus 3 plus 2 and call it 8x to the 6y to the 7th, or I'll miss a little bit. So I got to keep an eye on that. And as I go from problem to problem here, and I want to see some different ones here, because I'm going to leave you with some of these. So like, let's say we're looking at number 2. I only see one coefficient, so I get the 3 out there. Then when I go to my a's, if I add up their exponents, 3 plus 0 is 3. So I'll go ahead and get that put in. And then I remind myself that each of these b's that I see just has a 1 on it. So 1 plus 1 is 2. And I'm done. So that's kind of the gist of what I'm trying to do here as far as those go. And I always want to leave you a couple to be able to work with because, well, shoot, if you don't know what's going on yourself, watching this isn't going to help very much. So I'm going to leave 3 and 4 alone for right now and move down a little bit so we can work a little bit with our next group here, which is going to be power to power. Which again, when I see an exponent outside of parentheses, the parentheses are kind of the determining factor here. They help me see this right away. Power to power, I'm going to multiply exponents. But I'm still going to work with my coefficients the same. So I'm going to get my 1 in for any exponent. So I look at this and I say, okay, I have 2 to the 4th power. We'll simplify that momentarily. Multiply my exponents. 1 times 4 is 4. And then with my m's, again, I'm going to multiply my exponents because I'm going power to power. So once I've done that, I do need to do one more thing, though. And that's going to be, I've got to do 2 to the 4th. But remember, at 2 to the 4th, I can't just leave it like this. I can actually simplify that. Now, if I'm worried that I'm possibly going to do like 2 times 4, which wouldn't be right, it never hurts to go to the calculator and just use the exponent button, use the little caret button. Because that helps remembering, oh yeah, it's 2 times 2 times 2 times 2. And maybe I don't want to do all that in my head. So if that gets you sometimes, just go ahead, clean that up, and we'll be in good shape that way. And for any of these that you're going to work with an exponent, that's how we're going to do it. Same here. It's always going to go, uh-oh. Is it dead yet, though? Okay. Okay, as long as it doesn't end up shutting off. If it starts shutting off on you, let me know. We will immediately take care of it. So here, I'll deal with my 3 to the 4th in a minute. 0 times 4 is 0, so my x's are gone. Okay, I really don't want to put x to the 0. I could, but it's really not something I need to do. And then 4 times 4, bless you, is going to be y to the 16th. And again, if 3 to the 4th isn't something that just pops to you on the top of your head, and it doesn't for a lot of us, I always can just use the calculator to make sure I don't do something silly, like put like 12 or something like that. But my big thing on this one was 0 times 4 is 0. I can't just put a single x there, because that would be like saying it's 1, and it's not. So that kind of covers our power to power. What do I do when there's an exponent outside the parentheses? And again, I'm going to leave you a couple here for the time being to let you get some practice. So then we move up into our division. And again, when we're dealing with the exponent part, you subtract them and place the answer where the larger exponent is. So that doesn't apply to my numbers. So if I have numbers out front, I'd reduce them if I could, but if I can't, no big deal. I notice there's only a single x here, so I'm just going to leave it alone. But then with the y's, you subtract them. 4 minus 4 is 0. They wiped each other out, and I'm done. And that's always what I'm doing with these. My job with division always is going to be try and reduce fractions if you can, but if you can't, I don't want like 1.33. That's not going to do us a lot of good here. But for the rest of them, again, when you're dividing, just subtract. 4 minus 1 is 3. There's the bigger exponent. So I put my answer, my x to the third, up top. For the y's, I have 4 minus 0, which is 4. But the bigger exponent's down below in the denominator, so that's where my y to the fourth ends up. I can't do anything else because these aren't the same variable. So I can't like subtract again. They'd have to have the same base to be able to do that. So again, division, subtract the exponents, bigger minus smaller, put the answer where the bigger one's going to be at. So let's see what else we got here. Oh yeah, our buddies, the negative exponents. Now we're going to bounce around a little bit different on these. We're going to take a look at 13, and then we're going to go down to 15 here. So negative exponents, make sure we can squeeze this in here. If you get negative exponents, we want to flip them. What do you mean? Well, like for instance, on 13, what I would do is I'd look to see, okay, what have I got that I'm working with here? Well, I've got u. Oh yeah, anything to the 0 power is just going to go away. But for the moment, I'll leave it here. I've got my 1 on my u. U to the fourth is still a positive exponent. Okay, it can stay where it's at. But it's this guy. V to the negative third. Once I see a negative exponent, I want it to be positive as quick as I can make it positive. How do I do that? I flip it to the other side of the fraction. So since it's negative in the denominator, if I flip it up to the numerator, it becomes positive. And once that happens, now I can just go to my regular exponent rules to finish this off. So like if I'm looking at the u's, I'm like, ooh, I'm dividing. Okay, if I'm going to divide with them, I'm going to subtract and put the answer where the bigger exponent's at. 4 minus 1 on my u's is 3. Bigger exponent's down here. So u to the third. My v's are now in the same place. They're both up in the numerator, so I'm multiplying them. So I'm going to add their exponents. 0 plus 3 is 3. And I'm good. But it all comes back to, can I deal with that negative exponent? Can I get that to the spot where it needs to be? And also notice I'm only flipping if it's a negative exponent. Notice my u to the fourth didn't flip. V to the 0 didn't flip. U to the positive 1 didn't flip. The only one that flips is the negative. So if I get to a problem, let's say like 15, I go, okay. So on 15, I got parentheses. I always want to deal with those first. So I'm like, okay, so multiply those. Now, could I flip my negative exponent right now? I could. Probably isn't even a bad idea. So if I looked at this like it was a big old fraction, like it was a big old fraction over 1, and I said, okay, there's a couple of ways I could handle this. I could either say, well, the x to the 16th and the y to the 8th are both positive. I'm going to leave them alone. But this y to the negative third Yeah, I don't like the negative exponent. So notice, since it started up top in the numerator, to make it positive, I had to flip it down. So if I compare that up here, you're like, oh. So if it starts negative in the bottom, I put it up top, it's positive. If it starts in the top and it's negative, I put it down the bottom, it's positive. I always got to just flip it. Because then to finish, I only have one x term, but my y's, 8 minus 3, because I'm dividing, is 5. There's my bigger exponent. And you're like, well, what if there's nothing in the bottom? I can just put a 1 there, or I can just circle it the way it is. So I have to pay close attention to some of those little detail type issues. Let's see, I want to tackle a couple more of these. A couple of these are doozies. Actually, 17 and 18 look like a good place to go, just because it combines lots of stuff. Anytime I see parentheses, those get dealt with first. And it's okay if I've got to copy a few things over here. Now I do see it's going to be 2 to the 4th when I distribute. Let me get this over here. Oh, 2 to the 4th. I already got it here. 16. Okay. And then I'm multiplying exponents because of the parentheses, because of power to power. Okay, so I've got my denominator situated. Then I can turn my attention up top. So I look up top and I go, okay, well, I see a 2. I don't see any other numbers, so I'll put the 2. Then m's, I'm multiplying, so we're going to add them up. 2 plus 0 is 2. Then my n's, still multiplying, so we're going to add the exponents. 3 plus 3 is 6. And now I just got to simplify that fraction that's left. And again, be careful here, because you might look and you're like, oh, 16 divided by 2 is 8, and you just write 8. But be careful, that 8 would need to go in the denominator. And here's why. If I were to punch 2 over 16 in my calculator, and I don't want the decimal, so I'm going to math enter it. Notice it's 1 over 8. 1 over 8. And also that 16 is bigger, it kind of give me a clue that that's where my answer is going to be. But for the rest, no negative exponents. That's cool. So I'm just going to divide, or in other words, subtract my exponents. 8 minus 2 is 6. Bigger exponent down below. 8 minus 6 is 2. Bigger exponents down below. And we're good. So again, just take your time. Follow your rules, especially if you got your help sheet. I think there's some of these still in the Thursday folder. Was Thursday folder? I'm pretty sure over there that you'll be able to check those on. 18, always going to do the distributing first. All right, let's see here. Move this over a bit. Nothing to do up top. I'm going to leave that alone for now. Ooh, but as I get over here, I start looking, I'm like, ooh, negative exponents. Don't like those. So a to the negative 4th, I'm going to flip that up. That's going to become positive. B to the negative 3rd. Again, don't like the negatives. I'm going to flip that up to the top. Now I can start distributing through here. So 2 squared is 4. Negative 2 times 2 is negative 4, but I don't like a to the negative 4. So I'm going to flip it up to the top and make it positive right away. I want to get those negatives out of here. And then b to the 2 times 2 is 4, but it's positive, so I don't have to flip it. Only thing we're messing with on these are the negative exponents. That's why I put them in red, so you can see right away what's going to be going on with that. So now I got to simplify. There's a lot going on up here. So I got 2, let's see. B's, I got 1, 3 more is 4. Then my A's, I've got 3, and 4 is 7, and 4 more is 11. Yes, okay, thank you. So we've got our A to the 11. Let me just rewrite this for a second. So we got one more step, because I noticed a couple of things. I see numbers in both places. And again, if I'm not sure on the reducing, I always can get some assistance. with math enter, 1 over 2. 4 minus 4 is 0. If I get 0, it just means it's gone. And then I've only got that a to the 11th left, and I'm done. So you start to see, I think we hit everything that time. We did negatives, we did power to power, we did multiplying, we did divide. So that actually covered every single issue that we deal with. But again, I'll leave you a few to kind of play with. We'll get the key over here in a bit so you can kind of check that out. And then finally, we get back here to our growth and decay. And again, either of the notes that we did last week would be helpful for something like this. So it says, sketch the graph of the function, tell whether it's growth or decay, plot a minimum of 2 points. Okay, when I'm trying to figure out growth and decay, remember, it's all about that b value. It's all about the value that's with my x here. If it's bigger than 1, it's growth. If it's between 0 and 1, kind of more fractional, it's decay. But this is the value that determines that. So when I'm doing these, even before I put them in the calculator, I should know, for instance, that number 20 should be decay. And if I wasn't sure at the beginning, here's the other way I'm going to find out. When I go ahead and I put this in the calculator to help me. So I just type what I see, 2 times 1/3, and then use your caret button, your up arrow, or your exponent button if you're using a different calculator, and put the x power in there. Doing it in the y equals lets me do 2 things. One, it lets me see that it's decay because it's going down from left to right. And it also is going to help me when I want to find some values to help graph this. And I like the whole numbers, of course, because they're easier to look at. I don't think I can graph 54, though. So negative 218, that's doable. And negative 1, 6. And 0, 2. And then I start noticing it just gets smaller and smaller. But here's the one thing I've got to remember when I'm drawing this. It's not going to go below 0. Because whether you have bacteria or money or the value of your car, it's not going to go into a negative value. You're not going to have like negative bacteria or something like that. So you've got to make sure that it doesn't just like come through here and get sloppy. That's something I'm going to be watching for. But that's all I need to do on those. So for part of it, I should be able to just look at my b value and figure out whether it's going to be growth or decay. But there are some possible pitfalls with this. One of them being, if you get a fraction, I'd always make sure that I put it in parentheses, whether the sheet tells you to or not. So 1/3 times 5 to the x, because I don't want anything getting mixed up here. And I could use a multiplication dot in here like I did on this one instead of using the parentheses. That would be okay. But it also will let me look and say, okay, make sure I didn't do something screwy, because maybe this is decay. I'm not remembering. Oh yeah, it's growth. Up to the right. And then again, I can use the chart to hopefully find some values that aren't going to be too bad to deal with. But sometimes I may have to plot decimals, as I'm finding out right here. Normally when that happens, I will start at 0, and then I'll just start trying to plot some here, usually until I run out of room. Like for instance here, 3 is all the way up into the 40s. I don't have room. If I go the other way, they're all just getting close to 0. So I'm just going to stay real close to the axis and then make it go up really, really fast, because that's what my value would be. So these should be probably the easiest problems you have on the unit test itself, because the calculator, as long as you're messing with it in a decent way, should make this pretty easy. So again, just reminders, it's that value in front of x. Greater than 1, we're looking at growth. Between 0 and 1, we're looking at decay. And And the only other thing is just making sure that when we're typing it in the calculator, and again, if some of you are a little behind in that and going, now how's he getting to this? Just hitting y equals. And then basically just typing in exactly what I see. Notice this time I didn't use the parentheses, I just typed in what I saw. Now knowing ahead that it's growth though is going to help me. This graph should be going up to the right. And there it goes. And then to get the chart that I keep having up, it's the graph button again, except you hit second. You hit the yellow button before that. And I got some whole numbers to work with this time, which is good. And usually I know it says 2 points, but I normally will plot as many points as the graph lets me with my chart. Never going below 0 though. That's a no-no. You're always going to have a curve. It'll never be a straight line. Okay, it's not going to be a squiggle. It's not going to be any of that other stuff. And for each one, basically, I'm just going to have it identical to what I see. If they use parentheses, I'm just going to use parentheses. I probably could use the multiplication dot there too, but I'll get away with it. Should be going down to the right with decay. Yes. Feeling good about, ooh, lots of whole numbers. This is good. All right. So -3, a little above here, but I'll make it work. -2, 12. -1, 6. 0, 3. And as long as I can keep seeing them, I might as well use them. But do make sure that you read the directions carefully when you're doing these, because it says, you know, sketch it, tell whether it's growth or decay. So you can't just graph it, you've got to literally say which one it is. But the picture will help out quite a bit with that too. Then our story problems. The population of a city of 150,000 increases 3% per year. Determine the population of the city after some different times here. Use y equals a and then 1 plus or minus the percentage, and you only use one of these. I'm just not going to tell you which one, and look at the chart. So here it says increases. So for this one, increase means it's going up. I want to use the plus. So I've got y equals, my a value is what I start with, 150,000. 1 plus, then I got to think about this for a second. How do I write the 3% in? Can I just write 3? 0.03. And then you have a choice at this point. You can either, and I'll show you both, the t value would just be 2. So one of the choices I have, and this is especially true if you like using your own calculator instead of one of the graphing ones, you could go ahead, get out of the y equals part, and just type it in like you normally would. I just type what I wrote down, and then I plug a number in instead of it having been x. And whatever answer comes out would tell me what the new population's going to be. And then if I want to do it for 8 years, I just take the exact same expression, except this time, instead of plugging a 2 in for my exponent, I'm going to plug in an 8. And since we're talking about people, normally we don't talk about people as partial people, round to the nearest whole person. Some of you are like, well, is there a way it's faster? I really don't want to type this in twice. There sure is. I could take my initial expression, the 150,000, and the 1 plus 0.03, but instead of using the numbers, I can just use x. You're like, now why would you want to do that? Because if I do that the first time, I can go down to 2, I can get my answer, and then instead of retyping it, I can just go down to 8 and I can get my other answer. So you have options with these. They all are just depending on how you want to tackle it. But either one works just fine. And then 25 will do the same thing.
I accidentally called you Savage.
Thank you. So, last one here, or at least last story problem. You bought a new car. It costs $12,000, but it decreases in value 7% per year. Determine the value of the car the year after, okay? Decreases. We're using minus this time. So my expression would be my starting value 1 minus, remember it's not 7, it's the decimal form. And this time I'm going to go ahead and use x because I want to be able to do these both at once. I want to save myself a little time. So let me shift this over here. And I already got the y equals up anyway. And I'm just going to type in my starting value of the car. Since it's decreasing in value, unfortunately, I'm going to use the minus. And again, I got to use x if I want to take the shortcut. But I could plug them in individually the other way. So if I use my chart, let's see, 3 years. We can go to the nearest whole dollar. That's fine with me. So like after 3 years, it'd be worth about $9,652. And if I go to 10, looks like 5808 if I round up, because 80 cents would round up. Again, I can do them individually and just plug the number in if I want to, but to me that just works a little quicker and makes me a little happier that way. And then the last one, determine if it's growth or decay, no graphing. I suppose you could type it in the calculator, but at this point I think we know. Less than 1, decay. Greater than 1, growth. Now, couple of reminders. Tomorrow test basically is going to be this size. Well, actually it's a little bit smaller, I think. But have your exponents help sheet, have your notes from these ready to go. If you haven't done your growth and decay stuff, make sure that's ready to go because I'm pondering the idea of giving you the homework check on Wednesday. So make sure